welcome to Quadratics 1.2 Standard Form. Okay, so in this lesson I'm going to continue the introduction of quadratics, and I'm going to teach you about one key characteristic that, when present in the equation, makes this qualifies it as a quadratic function. Yeah, and that key characteristic is the presence of some kind of a letter squared. So in the equation we had from the previous lesson, it was p squared. For the purposes of today's lesson, it's going to change to x squared. Okay, and when you think about quadratic functions and you want to think about the general form of it, or how it normally looks as far as the appearance, you can use the equation that I just circled to show the pretty much standard form of what a quadratic function looks like. And it's basically x squared. Yeah, so some kind of number in front of x squared, plus or minus some kind of number in front of b, plus or minus some kind of regular number without a letter x at all next to it. Yeah, and when you see that form, yeah, that's what your typical quadratic function looks like. Okay, so make sure you remember now the presence of x squared or some kind of a letter squared qualifies it as a quadratic function. And one thing you want to remember is the number in front of x squared, which in this case we're going to call a. We're going to assign a letter a or a variable a to it. You want to make sure that a value is not 0. Yeah, and I'll explain why that's kind of important as we do some of the example problems in the next slide. Okay, but just remember those two things, right? It's a quadratic function when there's a letter squared, in this case x squared, and the number, yeah, which we're going to use a as a representative of whatever number we want to put in front of it. You want to make sure it's not 0. Okay, so let's move on to some of the problems. Okay, so we're just basically going to mark yes or no if it's a quadratic function or not, and if it's a no, then we're going to tell why. Okay, so in the very first problem, do we see a presence of x squared? Yeah, we do. X squared is there. Yeah, so since x squared is present and accounted for, we can mark this as a yes. This is a quadratic function. Good to go. Okay, so B, a little bit tricky because you see a x squared in the equation, but you also see a 0 in front of the x squared. So why is that a deal breaker? Why does this pretty much tell you that this is no longer a quadratic function anymore? Well, let me show you what that 0 does in front of the x squared. Okay, so if you think about the role of 0 multiplying to anything in the world, yeah, like 0 times a number or 0 times a letter or whatever it is, yeah, 0 tends to make things become 0. Yeah, when you multiply by 0, it makes things become 0 or basically just disappear. So when I multiply by 0 and x squared, the entire front part of this equation disappears. Yeah, so is x squared present in my equation anymore? No, it's not present anymore. And because it's not present anymore, we can no longer call this a quadratic function. Yeah, this is now a linear function because it's x to the first power. Yeah, so this is no longer a quadratic function. So we must mark no. Yeah, so actually let me just unerase that real fast because it might cause me stress later on when I do questions later on. Okay, so let me just erase it, and let's mark no in the no column, and the reason is because a was 0. Yeah, the number in the number in front of x squared was 0, and it causes the x squared to disappear. So yeah, if a value is 0, yeah, game over. That's not good. Okay, so number 3. So does the negative for 23 over 17, does that negative cause problems for x squared? Does it make it disappear? No, it doesn't. Yeah, x squared is still alive and kicking, is still good to go, so we mark a yes. Yeah, third one is good to go. Okay, what about the fourth one? Ooh, this guy's missing a regular plain old x. Yeah, he has the x squared, he has the regular number, 15, but he's missing the x. Is that a deal breaker? Is missing the x going to cause us to not call this a quadratic function anymore? No, it doesn't matter. Yeah, to be a quadratic function, all you need to make sure is you have x squared, and this guy has an x squared, so we're going to mark yes. Yay, good job. Okay, what about number 5? This guy has an x squared? He sure does. Does it matter that there's a negative in front of it? Is that negative going to cause the x squared to disappear like the 0 did? No, the negative's not going to do that. Okay, only a 0 can make the x squared disappear, so this guy also is yes, it's a quadratic function. Okay. What about, what is this, number 6? 1, 2, 3, 4, 5, 6. Yeah. Okay. What about this guy? Does he have x squared? No, he doesn't. Where did it go? Yeah. If the x squared's not there, what is the only number in the world that could make the x squared disappear? Yeah. Can a 1 make the x squared disappear? Can a negative 1 make the x squared disappear? Right? What's the only number in the world that can make that x squared disappear when it's right in front of it? Yeah, so first off, let's just call this answer no, okay? And the answer for this problem is, yeah, the a value was 0, and that's what made the x squared disappear. So yeah, let's stop putting zeros in front of the x squared, and we're going to have quadratic functions, okay? All right, what about this number 7? Okay, so this one is trying to get cute, and it's trying to write the problem out of order, and it's going to try to make you think that writing it out of order, yeah, where the x squared is not in the front and the 9's not in the back, it's going to make you think that this is going to cause us to ignore the rule about 0. Yeah, no, that doesn't happen. Okay, it doesn't matter where the x squared is, as long as it's in the function itself, then it's good to go. It's a quadratic function. Yeah. So because it's at the end, whether it's in the front, whether it's in the middle, whether it's at the end, it's good to go. It's there. Yeah, so my x squared is there, so this is going to be a yes. Okay, the last one. Okay, is he missing his x squared? Yeah, he is. Okay, what's the only number that causes that x squared to disappear? I think if you look two problems up or a number more problems up above that, you'll see the reason why. It's a is 0. Okay, so hopefully these 8 examples kind of taught you or showed you patterns about what makes something a quadratic function and what makes it not qualified as a quadratic function. So hopefully you caught on, and good thing this is a video, so if you need to see it again, rewind, feel free to rewind as many times as you need. Okay, good luck, and I will see you in class. Bye-bye.